Hello everyone. After a brief foray into the theoretical realm, we are back doing practical things in RStudio. In this video, we're going to talk about the dplyr package, and if you want something to follow along to read, this video will follow chapter 3 of R for Data Science by Hadley Wickham, and there's a link here you can follow to find that. So we're going to be studying this set of functions and a few others. And basically, dplyr is a way for you to subset data frames by rows or column, and then to do various operations, to do exploratory analyses with data frames. And actually, they have their own data type called a tibble, which is their version of a data frame. We're also going to talk about these join operations to combine different data frames. Okay, so let's get started. We're going to be working throughout this video with a data set on marathon performances. So let's read that in and just peek at the first 6 rows. So this came from a study that we did a few years ago to see how a new shoe called Nike Vaporfly affected marathon performance. So we collected a bunch of data on elite runners before and after this shoe came out and kind of tracked their performance over time and saw how much better runners did or worse after adopting the shoes. And what's kind of cool about the project is there are big databases of marathon performances, but there's no big database with what shoes people wore in marathons. So we had to comb through thousands of race photographs and manually identify what shoes each runner was wearing in each race. Okay, so this is the data. There's a few name columns. Basically, this is the raw name from the database. This strips off this age thing, male 25, and we had to do some manual matching of names because in some races the spelling was slightly different from entry to entry for the same runner. So match name is really the column that allows us to match runners together. And then there's which marathon they did. These are all from Boston Marathon in 2015. That's the date of the race. This is the time they ran in hour, minute, second format. And then this column just converts that to number of minutes. And then this is a true-false vector of whether or not they were wearing the Nike Vaporfly shoe. Okay, so that's the data. If we do class dat, that's a data frame. And we're going to be using dplyr. So I'm going to say library dplyr. And some messages pop up. Following objects are masked from package stats, filter, and lag. So we'll be looking at this. Basically, there's already a function in the stats package which gets loaded automatically called filter. dplyr has its own function called filter that overwrites this one when you load it. And then there's some others that are also overwrite functions from the base package. Okay, so let's take a look. I'm going to use table to get a count of the number of observations for each year. You can see the data starts in 2015 and goes to 2019, and these are the number of rows, which are performances in individual races by individual runners in each of the years. Now there's a dplyr function called filter. And the way this works is you give the data frame as its first argument, and then you give the conditions by which you would like to filter the rows. So what this does is it gets all the data where the year column is 2015. And then, so if I could do like dim dat has 880 rows, dim dat 2015 has 238, but all the same columns. And this 238 matches this, which is the count of performances in 2015. And then we could verify that by doing table of the year column from dat 2015. Of course, that's only going to have entries from 2015 because that's how we subset it. if we print this out, this prints out a big thing with 238 rows. And that's a bit much to take in. Sometimes you do want to print out the whole data just so you can look at it. But there's a data format called a tibble that comes as part of this dplyr package. And then there's a function called asTibble to convert a data frame to tibble. So if we do that, it's the same information that was in the original data set. So this thing is a base R data frame, and then this thing is a tibble. And one of the nice things about it is how it prints out the data frame. So everything gets kind of compressed here, and it prints out the first 10 rows and tells you that there's 228 more. And it prints out enough columns that only fit on the screen. And then it tells you at the bottom there's one more variable or column called Vaporfly. And it tells you how to see more rows. So we'll do that repeatedly in this video. The other nice thing it does is right below the name of each column, it prints this little message here that tells you the type of each column. So that can be useful. Sometimes things happen that you think a column is numeric or an integer or a double, but in reality it's a string, and that can cause problems. So this will tell you directly whether it's a character string. Do we have any? No, we don't have any like that. Okay. There's also a function called glimpse, which just prints out similar information in a different way. So each row in this output is a column from the data frame, and then it prints some information about each variable. Okay. All right, so let's do another example with filter. So what we're going to do here is filter the original data set. This is the full data set from all, how many years? 5 years. 15, 16, 17, 18, 19. And we're going to filter by this condition where the time is less than 127, which is 2 hours and 7 minutes, which is very fast for a professional marathon runner. And this is the result. So these are the 7 performances in the data set whose time is less than 207. And this is equivalent to the following. So earlier when we looked at the subsetting video, we did the subsetting in this way. Basically, we used double square brackets to subset a data frame, and we subset the rows according to this true-false vector, and then leaving this blank after the comma means take all the columns. So this is an equivalent operation. And one thing that can kind of trip people up who are new to using these packages and the tidyverse, dplyr is part of the tidyverse set of packages, is that this syntax may seem a little bit weird because, okay, so if you look at this thing, everything in here is, evaluates to something. So for example, dat $time minutes is an object in our workspace here. However, there is no object in the workspace called time minutes. See, error object time minutes not found. And so this may look like a piece of code that's not actually going to run, but of course it works. So what's happening internally is the filter function is interpreting this argument here, or this expression really, in terms of variables that belong to the dat data frame. Okay, so don't get tripped up by this. This may seem a little bit like a weird syntax, but this works just fine. You've seen this in other places in R, so it's not that weird. So for example, when you do lm y on x1 x2 x1 plus x2 data equals dat, the way this gets interpreted as y is a column in new dat, x1 and x2 are columns in new dat, but this, these objects wouldn't need to exist in the workspace. Okay. There's also a function called arrange, which can sort the data frame by some variable. So the first argument is a data frame or a tibble. So this is what we did above. And a range of that, according to time minutes, we'll just sort them so that the smallest value is at the top and the biggest value is at the bottom. And you can also use desc around the variable you'd like to sort by to sort in the opposite direction. Okay. And again, this won't work if you run it individually, but the arrange function knows how to interpret that in terms of a variable in this data frame. Okay, if you've seen dplyr code before, you probably don't see it written in this way. It's more often written using the pipe notation. So this, let's see, this line can be rewritten like this. Okay, so let me show you how these pipes get interpreted. So I'll just read this comment. The left side of the pipe operator, which is that thing, becomes the first argument to the function that's evaluated on the right side. So basically what's happening in this line of code is R is putting dat as the first argument to this filter function. So this becomes equivalent to this call right here. So this should do the same thing as above. And then what's cool about the pipes is you can chain them together. So this thing becomes the first argument to filter. And then the result of that becomes the first argument to arrange. So this line is equivalent to the following. So dat gets piped into filter, and then the result of that filter gets piped in as the first argument of arrange. So some people prefer this syntax. Some people prefer this syntax. Either way is fine. But you will see this a lot. So we're going to use this in this video as well. Okay, so this will do the same thing as filtering dat and then arranging it according to time minutes, and now they're in order. Okay, so that's filter is a function for subsetting rows of data frames or tibbles. For subsetting columns, the function is called select. And basically works by you give the data frame as the first argument, and then you give which columns you want to select from the data frame. Okay, so if I do this, this just pulls out match name, marathon, year, time, minutes, and vaporfly. Match name, marathon, year, time, minutes, and vaporfly from dat. You can also use sort of logical operations to select columns from the data frame. Let me put these in the opposite order. So if I wanted to get a data frame with just the names, I can say select dat contains name. This will pull out all columns whose column name contains the word name. And let's take a look at that. So that's name, age, match name, full name. So you could do these logical operations. This doesn't work. So you might think that it would know to use this as it is, but really these are kind of string operations. So this really should have quotes around it. So this won't work because there's no object called name. Okay, so that could be something that could trip you up. So these things have to have quoted strings. Okay, there's also a bunch of other logical conditions you can do. So if I look at the documentation, you can get a range of variables. You can use the not operator to get the complement of a bunch of variables, basically to say everything but these variables. You can do and or operators, and C for combining selections. There's also these helper functions. So this just says get everything, get the last one, select grouping columns, which we'll come back to later, starts with, ends with, contains, which is what we used, matches regular expression. There's a bunch of other these. So you'll be able to look at these. What we are going to look at here is the where function. So this allows you to do more customized operations. So let's see this. So what I want to do is I want to grab any column whose type is a logical. So in our data frame, that's just going to be the Vaporfly column. And I'm going to use pipes here just to show you how this works. So you say dat piped in as the first argument of select. So this will do something like this above. And then just for printing purposes, I'm going to pipe the result into head to just print the first 6 rows. All right, so that just grabs the Vaporfly column. And you can do more complicated things. So here I'm using the isLogical function. So basically it's going to apply this function to each column, and it's only going to return the columns where this returns true. So it only grabs the logical columns. But basically you can give it any function that returns a true-false vector for each column. And so here I'm gonna do isLogical or isNumeric, and then print the first 6 rows. So this gets year, time, minutes, and Vaporfly because these are the columns that are either numeric or logical. All right, next thing I want to talk about are grouping operations. And this is where the real power of dplyr begins to show. So basically, above we were subsetting rows and columns, which you can kind of already do in with regular R expressions. But grouping is something that doesn't really exist otherwise. So, and what this does is it operates similarly to split and tapply. So basically when we use split, we took a data frame and we split it up by the different unique values of certain variables. It works very similarly to that, but it comes with a lot less overhead, and in my opinion, it's a lot easier to use. So it's not quite true that you can't do these operations with regular R functions, but these grouped operations in dplyr really make it a lot easier, I think. Okay, so the way this works is I give it a data frame, and I give it which variables I want to group it by. So this is similar to saying split dat by marathon and year. So if we do dat grouped and then look at dat grouped, nothing's really changed. So it's really just the same data frame. However, this gets printed out here, groups marathon year 93. That means that there are 93 unique combinations of marathon and year. So basically there's 93 different races represented in this data set. And everything is the same though. So dim, dat, it's the same size. Unlike split, which returns a list of data frames. That's the same. If you look at attributes of dat grouped, let's start up here. It has the class. It's a grouped data frame. Row names, column names, which are just names in a data frame. And then it has these groups things. So this didn't exist here before we grouped it. And so this is a 93 by 3 matrix, which has one row for each of the unique groups. So in this case, each of the unique races in the data frame. And then it tells you information about each group. So the first one is Boston Marathon 2015. And there are 31 entries in the data frame for this group or this race. And then it has the counts for each of them. Okay. There's also a bunch of functions to get information about the groupings from the grouped data frame, which is really a grouped tibble in this case, because group by will always convert to tibble. Okay, so if I do group data of the thing we just created, det grouped, it returns this, which is basically the same thing as this groups attribute. So that's how to just grab that directly. Here, you've seen this get printed out here. I want to show you how this works. So as we said earlier, a tibble will just print out the first 10 rows if it's a big data frame. But it says at the bottom, use print equals print n equals whatever to see more rows. So you can say print group data dat grouped n equals inf, and that will print all 93 rows. So if you want to look at each race, you can do that there. By the way, you can do this with pipes. So you can say dat grouped group data print n equals inf. So that does the same thing. Okay, one thing I want to point out really quick is one mistake I've made, and you'll probably make at some point, is if you have an operation in this pipe chain that doesn't have any arguments. So basically, in here, group data has only one argument, which is the data frame. Because dat grouped is getting passed to the pipe, that means you put nothing in there because there's no other arguments. You can't do it like this. This will throw an error. It says pipe operator requires a function call as the right-hand side. So you actually have to call the function, and now it will put dat grouped as the argument, and then it will put group data of dat grouped as the first argument to print. Okay. Another function to get information about the grouping is called group keys. This just gives the groups as a data frame, but it doesn't have the counts. Another useful one is called group rows. And this is kind of cool. It returns a list. Let me go to the top of the list, where each list element tells you the rows that correspond to the indices of that group. So this means that the first 31 entries of the data frame are from the first group, which is Boston Marathon 2015. Let's print out a shorter one. So let's do that one. The fourth group is Boston Marathon 2018. So if I do dat grouped of group rows, dat grouped 4, all of these entries are going to be from Boston Marathon 2018. Oh, and by the way, this should not work. So dat grouped, you might try it this way. So you filter dat grouped by, actually, okay, dat grouped, yeah, filter. This is weird because dat group is appearing twice here. So filter group rows dat grouped 4. So what I'm trying to do is filter dat grouped by the indices that are returned by group rows of dat grouped. This doesn't work. And the reason it's not working is because this thing should be a logical vector in the filter function. So let's look at the documentation. All right, expressions. So the arguments for filter need to return a logical value and are defined in terms of the variables in data. If blah, 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 multiple expressions are included, they're combined with AND operator. So what's going on here and why this isn't working is because this thing gives the indices that correspond to the fourth group, as opposed to a big, long true-false vector, which is true in these entries, which is what would be required to pass it to filter. Okay, so here you have to do it this way. Okay, you can also get the group numbers of each index. So what gets returned here is a vector that's the same length as the number of rows in the data frame. And for each row, it tells you which group it belongs to. So this has 880, I believe, entries. And this is telling you that the first 31 entries of the data frame belong to the first group, which is Boston Marathon 2015. Okay. Oh, yes. So this is grabbing the first 31 rows. And there's a function called distinct, which will return the unique values of the columns in that data frame. So what's happening here is I'm piping the first 31 rows into the first argument of distinct, and then saying get the distinct values of marathon and year. And as you'd expect, what gets returned is just a single thing, Boston Marathon 2015. That's because these first 31 rows only correspond to Boston Marathon 2015. There's no other races in the first 31 rows. Okay. There's some other functions. Groups just tells which grouping variables you used. Group size tells you the size of each group. So this says there are 31 entries for Boston Marathon 2015. N groups tells you the number of groups. In this case, there are 93 unique races. Okay, so group by is a function that basically imbues the data frame with attributes about the groupings of the data frame. And you could do it by whatever variables you want here. That's useful on its own. For example, if you have a big data frame and you want to keep track of which indices correspond to the different values of the groups. Like for example, in here, if I want to be able to work with this data frame a lot and repeatedly, quickly look up which rows correspond to each race, I can group the data frame and then get the indices for each group. And then if I want to look up, okay, which rows of the data frame correspond to Cal International Marathon 2018, well, I just grab the appropriate element of this list and then use it to subset the data frame so that I can quickly do it. So it's useful on its own, but it's actually most often used with another dplyr function called summarize. So this is really cool. So here we have our group data frame by marathon and year. And if we pass it into summarize and then give it a function to evaluate, what this will do is it will evaluate the function mean of time minutes on each group, and then it will return a data frame. So let's take a look at that. So this is now a 93 by 3 data frame because there are 93 groups. There's a column for the grouping variables, and then now there's a new column for the average time for that race. So in this case, Boston Marathon 2015, the average time was 138 point something. It didn't print out the point something. You can also give it variable names. So I could say average time equals, and that will do average time here instead of this kind of nasty looking column name here. Okay. There are various functions you can use any sort of function you want, but this is a handy one to say dat grouped n, which just counts them up. And you can actually bypass the grouping operation because there's a dplyr function called count where you can just supply the data frame and then the groups that you want to count by, and it will return a similar thing. In this case, it's returning a data frame, but this is all the counts. It's the same information that's in here. So these two return the same information. Okay, so let's look at some more examples with summarizing. And for here, we're going to use pipes so you can get used to using these. So basically, dat's going to go as the first argument to group by. The result of this function call will go to the first argument of summarize, and then the result of that will go to the first argument of print. So we're going to take the data frame, we're going to group it by marathon, year, and vaporfly, which is a logical true-false. We're going to summarize that group data frame by calculating the average time for each group, and then we're going to print the result. Okay. So this has now 147 rows. Why is it not 93 times 2? That's because there are not every race had both conditions, true and false, of the vaporfly variable. So it's less than 93 times 2. But you can see that it's returning a big data frame that has different conditions. So let me give you an example. So here, 2018, there were instances of both runners without vaporflies and runners with vaporflies. This is the average time when this condition was met, which means runners in Boston Marathon 2018 who are not wearing vaporfly shoes, this was their average time. And this means the average time of runners in the 2018 marathon who were using vaporflies was this time, which happens to be 3 minutes slower in this case. Okay, so let's do another one. Same grouping. You'll see here that you get some NAs here. That's because some of the vaporfly variables are missing. We weren't able to identify the shoes for all of them. So there's actually 3 entries here. So what this means is for Chicago Marathon 2017, there were people with and without vaporflies, and there are also people who had a missing value for that variable, and this was their average time. So you might say, okay, so let's just remove the missing values when we return the mean. But that actually doesn't do what we want. What we really need to do is first remove, if we want to get rid of these, what we really need to do is first remove those rows for which the vaporfly is missing, and then do the operations. So what I added here is a filter operation at the beginning that gets rid of any row that has a missing value for vaporfly. A better way of saying that, it keeps any row that does not have a missing value for vaporfly. Then it groups, then gets the average time. All right, so now those NAs are gone. Okay, and here I'm trying to rectify this situation where, because I really want to see the decimals. So what I'm doing is filtering again, grouping, summarize, and then I'm converting it back to a data frame and setting the digits argument to be 5. That prints out the decimals, so I can actually look at the times in a little bit more granularity. Okay, so let's finish up with a little project here. Basically, we want to do an exploratory data analysis. that looks at the average time in each race for runners with the Vaporfly shoes and runners without the Vaporfly shoes. And in order to look at the data, I want to have each row be a race, and then I want to have a column for the average time of people with Vaporflies and another column for the average time without Vaporflies, so that we can compare them a little bit easier than trying to look at these true-false values and making sure these are matched up. Okay, here's what we're going to do. First thing I want to do is calculate the averages using group by and summarize. So this is what we did before. And let's just print out dat averages. All right, so this is just repeating what we had before. So this is all the information we're going to need. But basically, I want to reshape this so there's only one row for each race and multiple columns for the average time with and without Vaporflies. Okay, so the tactic I'm going to take is I'm going to create two data frames. One by filtering this average data frame by not Vaporfly, and another one for filtering it with Vaporfly. So if I look at this one, the Vaporfly column is all going to be false here. And in this one, the Vaporfly column is all going to be true. And that's head. Actually, let me get rid of head here, because we want to look at the number of rows in these. Okay, so the false one has 85 rows. The Vaporfly true one has 36 rows. And so now the problem is, okay, how do we combine these when the conditions are different in each one? So basically, this one has a lot more conditions than this one. So you can't just like C-bind them together, because they don't have the same number of rows and they won't match up. So there's a function, various functions in dplyr for joining data frames. In base R, you might do a merge, but personally I prefer these because merge does things that you don't expect, like reordering rows and columns, and I find these join functions to be easier to use. Okay, so the first one we're going to look at is called left join. What it does is it tries to match the second argument, which is a data frame, to the first argument. And the idea is when you're going to basically take this one and try to join it to this one. And we're going to keep all the rows in the original one and only match the rows in this one that have a matching value in this one. So the result should be another 85 by 4. Sorry, it should be another 85 row data frame. There's an argument called by. That's how we're going to do the matching. So basically, I won't only want to match up this data frame to this one if both the marathon and the year match. So let's show an example here. So Boston Marathon 2015. There's actually no entry in this one here, so it shouldn't do any matching on that one. But there is Boston Marathon 2016, so it should match this value, the rest of the data frame, which is the true and the average time, to this one. Okay, so let's do this. All right, so that worked. You can see this has 85 rows, and the true data frame, this left data frame has 85 rows. The right data frame, which is the true, has 36. The both data frame has 85 because we're matching the right to the left. And if we take a look at this, you can see that indeed there's no match for Vaporfly. Sorry, there's no match for Boston 2015. Because that didn't exist, but there is for 2016. So these get matched here. So this is almost what we want, but not quite. So basically what it did is it took every column that wasn't specified by and matched them up. And you can see that there's a vaporfly column in both, and there's an average time column in both. And so when it matches them up, it has to say, okay, which is which. And by default, it renames the column to .x and .y here. We'll see in a second how to modify that. And so that's why you get vaporfly.x. So this is the value from the false data frame. Average time x is the average time from the false data frame. This is the true. That's the true. Okay, so this is not quite what we want, because actually we don't even need the vaporfly column if we give an informative column name to these average time things. Okay. All right, so what we're going to do first is we're going to filter take dat average as false, and instead of just filtering by here, we're going to select everything but the vaporfly column. So this is similar to this call up here, but at the end we're going to get rid of the vaporfly column. All right, so we're rerunning this, and just take a look at this. Dat average is false, good. Dat average is true, good. And now we're going to join them up. This time I'm going to do an inner join. What inner join does is it only creates a data frame that has a match in both the left and the right data frame. So this should return 85, actually it should return 36 or fewer, because that's the smaller of the two. But the by is the same. And then the suffix that we're going to apply to all the other variables is, for the false data frame, I'm going to do underscore false. For the true data frame, I'm going to do underscore true. Okay, so let's do this. Yes, and this returns the 31 races that have a match in both, that have a time for non-vaporfly and vaporfly. And I'm printing them out here. So Boston Marathon 2016 was one of the examples. These are the differences in the times. Okay, so if we just start staring at these, 2016 average time was 10 minutes faster. 2017 average time was 6 minutes faster. 2018, the average time was 3 minutes slower with the vaporfly. 2018 was a really weird year at Boston because the weather was super bad. There was like 35, 40 degrees and a headwind, and raining and a headwind the whole way. So a lot of crazy things happened there. And then 2019, things kind of went back to normal. Vaporflies were 3 minutes faster. Okay. Now this is good because I can kind of look through here and compare the numbers. That's good for the exploratory analysis. But I want to do one more thing. I want to add a column for the difference between these two, because that might be a little bit easier to look at. And to add columns to tables, you can use the mutate function. And basically what this does is it's going to create a new column called average time diff, which is the difference between the true and the false column. So that's that. And then here I'm doing the same thing, but I'm just sorting by year and printing them all out. So this is the result. The cool thing about Tibbles is they'll print negative values in red. So you can kind of just quickly scan through these and see that most of them are red, which means that most of the time the vaporfly people ran faster than the non-vaporfly people. It's kind of cool. Okay. Last thing I want to do real quick is show how we analyze the data in the paper. We actually fit a very simple model. So basically in this analysis, you want to control for a couple of things. One, of course, you want to have a vaporfly variable in the model, dummy variable, yes or no, to get the effect of how much faster people are running with the vaporfly versus not. You also want to control for the difficulty of each race. So I mentioned Boston Marathon 2018, which is a very slow year because the weather was really bad. So that's going to kind of affect all runners in that race. And then certain courses are faster or slower than others. And then I also want to control for the runner. So some runners are just better than others. And so what you don't want to happen in your analysis is, so for example, here, this is a good example because the vaporfly people were 10 minutes faster than the non-vaporfly people in Boston Marathon 2016. And what happened that year was that the shoes had not been released to the general public, and the only people wearing them were like Nike's top athletes. So this is a situation where the whether or not you're wearing a vaporfly depends very much on whether or not you're a top runner. So this number is a bit misleading because we're not really controlling for the quality of the runner. And this analysis does. I'm also creating a variable called marathon year so that we can have a distinct variable for each race. Okay, and I'm using the LMER function from the LME4 package, which fits a random effect model. So basically the response is the time. There's a fixed effect for vaporfly, false or true. And then there's random effects for race and person. And here's the summary. This fits really fast. And the way you look at this is this part of the output gives you the estimates for the variances of the random effects. So, and then also reports the square root of the variance, which is standard deviation. So the runner contributes on average 4.2 minutes of variation. The race contributes a smaller amount, 2.3 minutes. So basically what we're saying there is a good runner on a slow course will still run probably faster than a slow runner on a fast course. So the effective runner is bigger than the effective course. And then there's error on top of that, about 4 minutes. But the cool part, the punchline down here, is the way you interpret these numbers is that this is the expected time for people not wearing the vaporflies, 139 minutes, which is 2 hours, 19 minutes. These are professional runners. And then this is the expected difference in time between someone with the vaporfly versus not the vaporfly. And the punchline is that they're estimated to run 3 minutes faster. And the t-statistic is -5, which is like wildly significant. So this is a significant result that the vaporflies make you about 3 minutes a mile faster in this data set, which is a big effect in a marathon. For people like this is over a half mile advantage if you wear these shoes. Okay, so that's it for dplyr. I think this makes a lot of exploratory analyses a lot simpler and easier to code up, and should make your data analysis a lot cleaner. See you next time.